Dear students, under the topic vector differentiation, we are going to learn the maximum directional derivative. Already we have learned how to find the directional derivative, and that directional derivative is maximum in the direction of nebula phi. So in the direction of nebula phi, the directional derivative is maximum. And the maximum value of the directional derivative is evaluated by taking the magnitude of nebula phi. So the magnitude of nebula phi gives us the maximum value of the directional derivative. And the directional derivative is in which direction? It is maximum. It is maximum in the direction of nebula phi. So these two concepts we should understand very clearly. And the unit vector in the direction pertaining to the maximum directional derivative is given by nebula phi divided by modulus of nebula phi. We know that the unit vector of a vector A, suppose if we have a vector A vector, the unit vector for this is evaluated by taking A cap, which is equal to A vector divided by modulus of A vector. This is the basic concepts of vector analysis. So since this is the unit vector, here the maximum directional derivative is in the direction of nebula phi, and therefore the unit vector in that direction will be nebula phi divided by modulus of nebula phi. It is obtained by this concept. So therefore, always remember the directional derivative is maximum in the direction of nebula phi, and the maximum value of the directional derivative is the magnitude of nebula phi, which is obtained by taking the modulus of nebula phi. And then the unit vector in this direction is given by nebula phi divided by modulus of nebula phi. So by all this we understand that the directional derivative is always a scalar quantity, that is, it is independent of the direction. So in this video lecture we will learn how to find this maximum directional derivative. Now here in this question, they are asking us to prove that the directional derivative of phi equal to x cube y square z at 1, 2, 3 is a maximum. So that is, we have to find nebula phi first, and we have to check whether it is maximum in that direction. And all this we have to find along the direction 9I vector plus 3j vector plus k vector. So now first of all we will find nebula phi for that. So this is the formula for nebula phi. The 5 given over here is x cube y square z. Now from this, what is dou phi by dou x? It is equal to, we have to differentiate this partially with respect to x. So it will be 3x square, and y square z will remain as it is because they will be treated as constants. Similarly, dou phi by dou y we have to find, which is the differentiation of y square, and that is 2y. So it will be 2x cube y z. And then dou phi by dou z, which will be equal to, the differentiation of phi is partially with respect to z is, differentiation of z is 1, and so it will be x cube y square. So after finding this, we have to substitute in this formula. So it will be nebula phi will be equal to 3x square y square z I vector plus 2x cube y z j vector plus x cube y square k vector. Now this is at the point given here is 1, 2, 3. So this we have to find at the point 1, 2, 3. So nebula phi at the point 1, 2 and 3 is equal to. So at the place of x we have to put 1. At the place of y we have to put 2, and at the place of z we have to put 3. So when we do so, it will be, here it is 1. So 3 multiplied with 1 square, and then y is 2. So 2 square multiplied with z is 3 I vector plus 2 multiplied with 1 cube, and y is 2 and z is 3 j vector plus we have x cube, so that is 1 cube, y square is 2 square k vector, and so this is equal to, so we know that 2 square is 4, and this has to be multiplied with 3. So 4 3 times is 12. 12 multiplied with 3 is 36. So 36 I vector plus. Now here 3 2 times is 6. 6 2 times is 12. So 12 j vector plus 2 square is 4. So 4 k vector. So we have obtained nebula phi at the point 1 comma 2 comma 3. We know that the directional derivative is maximum in the direction of nebula phi. So therefore we will take and write this. So I've taken and written the directional derivative is maximum in the direction of nebula phi. But what is nebula phi? It is 36 I vector plus 12 j vector plus 4 k vector. We can take 4 common from all the three terms, and so we will be having 4 multiplied with 9I vector plus 3j vector plus k vector. But what is this direction? This is the direction that is given in the question. That is, we have to prove that the given phi is the directional derivative of phi is maximum along this direction. So therefore we have proved that it is maximum along the direction, that is 9I vector plus 3j plus k vector, since 4 is a scalar. So now next we have to find the maximum value of the directional derivative, and it is given by the magnitude of nebula phi. So I have taken and written here the maximum value of the directional derivative is equal to modulus of nebula phi. Now what is nebula phi? It is equal to 4 multiplied with 9I vector plus 3j vector plus k vector. Just now we evaluated this. Now we shall substitute that over here. So what we will get the maximum value of the directional derivative as? So that will be equal to modulus of 4 9I vector plus 3j vector plus k vector. Now this 4 is a positive value only, so it can be taken outside the modulus. So 4 modulus of 9I vector plus 3j vector plus k vector. Now we will apply the formula for modulus, which is equal to 4 multiplied with the square root of, what is the component of I? It is 9. So 9 square plus, what is the component of j? It is 3. So 3 square plus, what is the component of k? It is 1. So it is 1 square. And so that is equal to 4 square root of 9 square is 81, 3 square is 9 plus 1 square is 1. And that is equal to 4 square root of 9 plus 1 is 10, and 81 plus 10 will give us 91. Therefore, the maximum value of the directional derivative is given by 4 square root of 91. So this is the required answer. So hope you have understood this problem. We will see a similar kind of problem in problem 10. So here we have problem 10. The question is, find the directional derivative of phi equal to 3x square plus 2y minus 3z at the point 1 comma 1 comma 1 in the direction specified by 2I vector plus 2j vector minus k vector. So the first question is, we have to find the directional derivative. And the second question is, also find the maximum value of the directional derivative at that point. So at that point we have to find the maximum value of the directional derivative. And the unit vector, the third question is the unit vector of the direction pertaining to this maximum. So this is a unit vector pertaining to this maximum direction we have to find. So there are three questions in this problem. The first question is, we have to find the directional derivative of the given scalar point function, and then we have to find the maximum value of the directional derivative, and the third question is unit vector pertaining to this maximum direction. So let us see one by one. First we shall find the directional derivative. How to find the directional derivative? We know that the directional derivative is nebula phi dot product with the unit vector e. So first we shall find the unit vector e along the given specified direction, that is 2I plus 2j minus k vector. Then we will find nebula phi and take the dot product in order to find the directional derivative. So if you see the previous video on directional derivative, you will understand this better. So let us do that now. So first we will take and write this given direction, and we shall represent it as d vector. And what is the direction given? 2I vector plus 2j vector minus k vector. And we all know that the unit vector along this direction is given by d vector divided by modulus of d vector. So using this, what will be the unit vector along this direction? It will be equal to 2i vector plus 2j vector minus k vector divided by, what is the modulus of this? It will be square root of sum of the square of each of the components. Now if you see 2 square plus here also you have 2, so 2 square plus here you have minus 1, so minus 1 square, and so that is equal to 2i vector plus 2j vector minus k vector divided by square root of 4 plus 4 plus 1, which is 8 plus 1 9. So square root of 9 is 3, and so therefore the unit vector pertaining to this direction is 2i plus 2j minus k vector divided by square root of 9 is 3. So this is the unit vector. Now after finding the unit vector, we shall find nebula phi. So what is nebula phi? It is equal to, so this is the formula for nebula phi. Now we will take and write phi first. So phi is equal to what it is? It is given by 3x square plus 2y minus 3z. So let us write that. So phi is equal to 3x square plus 2y minus 3z. Now we shall find dou phi by dou x, dou phi by dou y, and dou phi by dou z. So dou phi by dou x is equal to 3 2 times is 6, so 6x, and these two become 0. Next we have dou phi by dou y, which is equal to, these two terms will become 0 and you will be left with 2 over here. And then dou phi by dou z, so differentiation, partial differentiation with respect to z. So these two terms will become 0 and we will be having minus 3. So after finding this, we shall substitute here in order to find nebula phi. So nebula phi will be equal to 6xi vector plus 2j vector, okay, minus 3k vector. So we have obtained nebula phi. Now we have to find nebula phi at the given point. So what is the given point? It is 1 comma 1 comma 1, so which is x y z. So a value of x is 1, y is 1, and z is 1. So if you see here, we do not have y and z, so only x is there. So value of x is 1. So therefore the value of nebula phi at the given point 1 comma 1 comma 1 is equal to, if you put 1 here, it will be only 6. So 6i vector plus 2j vector minus 3k vector. So we have obtained nebula phi. So now we have to find the directional derivative, which is dot product of nebula phi and E vector, E cap. Already we have found these two values, so we shall substitute them. Nebula phi is 6i vector plus 2j vector minus 3k vector. And this has to be taken a dot product with, what is E? That also we have found now. 2i vector plus 2j vector minus k vector, the whole divided by the constant 3. So that's equal to, this 3 we will have it as it is. I told you already, dot product means you have to multiply only component wise. So 6 into 2 is 12, and then you have to add them. So 2 into 2 is 4, and then minus into minus will become plus. 3 1 times is 3. And finally that is equal to, what is 12 plus 4 plus 3? It is 19. So 19 divided by 3. So this is the directional derivative. If you can write it as a mixed fraction, we know that 3 6 times is 18. So the mixed fraction will be 6 1 by 3. Because when we divide 19 by 3, the quotient will be 6 and the remainder will be 1, and the we know that we are dividing by 3. So therefore it can be written as the mixed fraction 6 1 by 3. So after writing this, we will move on to the second question, because we have found the directional derivative. So that was our first question. Now the second question is, here we have also find the maximum value of the directional derivative. We know that the maximum value of the directional derivative is given by magnitude of nebula phi. So modulus of nebula phi. We have already seen when we learned the formula. So the maximum value of the directional derivative is modulus of nebula phi. So let us find that now. So I have taken and written that So what is modulus of nebula phi? So this will be equal to modulus of, we know that nebula phi just now we found 6i vector plus 2j vector minus 3k vector. Let us substitute that here. Now if you want to take the modulus of this, it will be equal to the square root of 6 square plus 2 square plus minus 3 square. And so that's equal to square root of 36 plus 4 plus 9, which is equal to square root of 49, and we know that square root of 49 is 7. So therefore the maximum value of the directional derivative is 7. Now we will move on to the next question. So what is the third question in this problem? The third question is, we have to find the unit vector of the direction pertaining to this maximum. So we have to find the unit vector of the direction pertaining to the maximum. We know that the direction pertaining to the maximum is in the direction of nebula phi. So this we all know. So the direction pertaining to the maximum is in the direction of nebula phi. But what is the question here? The question is to find the unit vector of the direction pertaining to the maximum. So if nebula phi is the direction pertaining to the maximum, what is the unit vector? We all know that how to find the unit vector. It is given by nebula phi divided by modulus of nebula phi. So using this concept of unit vector, we have to find the unit vector of the direction pertaining to the maximum. So we have to find nebula phi by modulus of nebula phi. So let us do that. So therefore the direction pertaining to this maximum is in the direction of nebula phi. Therefore the unit vector in the direction pertaining to this maximum is nebula phi divided by modulus of nebula phi. I have just taken and written whatever I told you. And that is equal to, what is nebula phi? Just now we found it. 6i vector plus 2j vector minus 3k vector divided by, what is modulus of nebula phi? That also we found here. That is modulus of nebula phi was 7. So we will write 7 here. So therefore this is the unit vector in the direction pertaining to this maximum. If you want, you can just simplify further. That is, just separate the denominator. So 6 by 7 I vector plus 2 by 7 j vector minus 3 by 7 k vector. You can leave it as it is, or you can also write in this way. So both are correct. So hope you have understood both the problems that we learned in this video. In our next video, we will learn how to find the scalar point function phi when the gradient nebula phi is given. So usually the scalar point function phi will be given. Usually phi will be given. From this we were finding nebula phi. Now in our next video we will learn how to if nebula phi is given, how to find this phi. So that will be the concept that we will be learning in our next video. So kindly follow the next lecture. Thank you.